The following energetics question is about figuring out the activation energy of a reaction or estimating the activation energy of a reaction. And the question states that which stage in the free radical substitution of ethane by chlorine will have the lowest activation. Now, we want to figure out which reaction, and we need to estimate which reaction is going to have the lowest activation energy. Remember, we first need to figure out what is activation energy. Activation energy, or EA, is known as it is the amount of energy that is needed to start or activate a reaction. So it's the amount of energy needed to start a reaction. But why do reactions need energy initially? The reason why reactions need energy initially is, for example, if I take a simple reaction. Let's think of a simple reaction. Let's think of hydrogen reacting, burning in oxygen and producing an H2O molecule. So let me write an equation and balance it. So if I draw the structural formulas of these compounds, it's going to look something like this. They're two hydrogen molecules. A hydrogen molecule is H2, where two hydrogens are bonded to each other. So there are two hydrogen molecules reacting with an oxygen molecule. Oxygen and oxygen atoms form double bonds, and they're forming two water molecules. Now, if you look at this reaction carefully, every reaction, the first step involves the breaking of bonds. So initially, very initially, in the beginning, you need to get rid of the HH bonds. So you need to break bonds. So the bonds broken are, you would break two hydrogen-hydrogen bonds, and you would also break an oxygen bonded to an oxygen, because you need to get rid of those bonds. And then once those bonds are broken, you would form bonds. So new bonds would be formed, and in this case there would be bonds being formed between oxygen and hydrogen atoms. So there's one over here, one over here, one over here, and this is the fourth one over here. So there would be four OH bonds that are formed. So whenever you have a reaction, there would be, the first step usually involves the breaking of bond, and once those bonds are broken and the atoms are free, they then form new bonds, and new bonds are formed. And so this first initial step is endothermic. It's endothermic, and this second step, which involves the formation of new bonds, is exothermic. So the reason why reactions require energy initially is because initially old bonds or old attractive forces, etc., or intermolecular forces need to be broken. You need to set the atoms free so that they can rearrange and form new bonds. So this initial step requires energy. It requires energy, and this is basically your activation. This is the energy that is needed to break the old bonds. So any reaction, if a reaction requires a lot of energy to break the old bonds, then that reaction has a very high activation energy. If a reaction requires very less energy to break these old bonds, then that reaction has very low activation energy, and that reaction would be faster, because it's going to be very easy. If it becomes very easy to break the oxygen bonds and the hydrogen bonds over here, then that reaction would be very fast. If it requires a lot of energy, a considerable amount of energy to break the oxygen-oxygen bond over here, then this reaction would be very difficult to carry out. So any reaction that requires very less energy or doesn't even involve bond breaking, that reaction would happen at a very fast rate, and it would have a very low activation energy. So if you now we're going to go to the option. We're going to start checking each option one by one. So if you look at the first option, a Cl2 molecule is getting converted into two Cl atoms. This dot over here represents unpaired electrons. So don't get confused with these dots. This single dot represents a free radical. It means that the atom has incomplete bonds. It has unpaired electrons, and it would be, for example, chlorine. A single chlorine atom would have 7 electrons in its outer shell, so it would need 1 electron. So this dot basically represents that the bonds of the atom are incomplete, or the bonds of the molecule are incomplete. So don't get confused with this dot over here. You can ignore the dots. Even then the question would be solved easily. So this first reaction, a Cl2 molecule is getting converted into two Cl atoms, which means that you would be breaking a Cl-Cl bond. Now, breaking the Cl-Cl bond would require energy. So this reaction would have activation energy. Otherwise, so it would need energy to break this Cl-Cl bond. So hence, this would have some activation energy. Moving to the second question. If you look at this question, you would notice that C2H6 gets converted into C2H5 in the product, which means that a C and an H bond is broken. It is broken because initially you had C2H6, the two carbons bonded with 6 hydrogens, now the two carbons bonded with 5 hydrogens. So there is bond breaking going on. You need to break the bond of the hydrogen with the carbon. So since bond breaking is going on, that means this reaction requires energy. If you look at option C, C2H5 is reacting with Cl2 and it's forming these two products. And if you look carefully, the Cl-Cl bond is broken because in the product you're only left with one Cl. So in this reaction also, initially you would have to break this Cl-Cl bond. So that bond would be broken. So there would be some activation energy, some energy would be needed at the start of the reaction to break the bonds. But if you look at option D, this Cl goes and bonds with C2H5 and forms a single product, which means that there is no bond breaking going on. No bonds are actually broken. The only thing that's happening is a bond formation. This carbon is actually forming a bond with Cl. No other bonds are being broken. So no bond breaking occurs. So if no bonds are being broken, that means it doesn't need energy initially. It's only forming a bond. Hence this option, option D, is going to be the correct option. It's going to have a very low activation energy because it doesn't involve bond breaking in the first place. So no amount of energy is needed to break any bond in this reaction.